To multiply rational expressions, the first thing we want to do is completely factor all the polynomials, both in the numerator and the denominator. Second, we want to cancel any factors that are shared between a numerator and a denominator. And then finally, we're going to multiply the remaining factors straight across, numerator times numerator, denominator times denominator, to get a single fraction. When dividing rational expressions, we're going to use the reciprocal to change the division problem into a multiplication problem, and then continue to follow the steps above. Example 1b, multiply or divide is indicated. Write the result in lowest terms. 3 over 4y minus 28 divided by 9 over 6y minus 42. So recall our first step is to invert the second fraction. That is, rewrite this division problem as a multiplication problem. So we have 3 over 4y minus 28 divided by 9 over 6y minus 42, which is the same thing as times 6y minus 42 divided by 9. So we've inverted our second fraction. All right, next we want to factor numerators and denominators. All right, noticing 3, we can rewrite 3 as 3 times 1. And 4y minus 28, okay, so this is a polynomial. To factor polynomials, we have to use one of our methods discussed from the factoring module. So that is, in this case, we're going to factor out the greatest common factor. Notice that 4 divides into 4y and 28. So we're going to take a 4 out, take out the greatest common factor of 4, and that's going to leave us with y minus 7 in parentheses. In other words, 4y minus 28 is 4 times the quantity y minus 7. 6y minus 42. Again, we can factor out the greatest common factor. That factor again would be 6. 6 goes into 6y and 6 goes into 42. So in parentheses we have y minus 7. 6 times y is 6y. 6 times negative 7 would be negative 42. Finally, let's factor the 9, and that can simply be written as 3 times 3. Now notice we can go one step farther. This 6 and this 4 can also be factored down. So let's do that. On the top I have 3 times 1, and on the bottom for 4 I have 2 times 2 and then times y minus 7. And the 6, that can be written as 3 times 2 times y minus 7 all over 3 times 3. I will point out that sometimes you can reduce numbers in your head. Sometimes you're good and you can do it without listing all the factors out, but I'm going to do that to be rigorous and show you exactly where everything is coming from. Alrighty, so what was our first step? We inverted. So we inverted our fraction first. Then we factored everything out as far as possible, and now we're going to cancel any common factors from the numerator and the denominator. Well, let's start with this 3. This 3 will cancel with this 3, leaving us with 1. This 3 will cancel with this 3, leaving us with 1. And one of these 2's will cancel with this 2. Do you see anything else? Ah, yes, the y minus 7. Do you see the y minus 7 quantity? It appears in both the numerator and the denominator, so we can cancel that as well. Alrighty, I don't see anything else we can cancel. Now we can multiply straight across. 1 times 1, 1 times 1 times 1 times 1. On the top, that simply gives us 1. And 2 times 1 times 1 times 1 times 1, that simply gives us 2. And so our final answer is that 3 over 4y minus 28 divided by 9 over 6y minus 42 is simply equivalent to the fraction 1/2. Make sense? Example 1c, multiply or divide is indicated. Write the result in lowest terms. 2x squared plus 5x over x squared minus 16 times x squared plus 3x minus 4 over 2x squared plus 3x minus 5. All right, this is multiplication, so we don't need to flip anything. Our first step is to factor the objects or the polynomials in the numerator and the denominator. So let's start with 2x squared plus 5x. Notice the greatest common factor here and here that we can pull out is simply x. And that's going to leave us with 2x plus 5. Underneath we have x squared minus 16. Notice this polynomial is a difference of squares. That is, it's factored as x minus 4 times x plus 4 because x squared and 16 are both perfect squares. Let's take a look here. X squared plus 3x minus 4. Now, this is a trinomial. This trinomial factors as x plus 4 times x minus 1. And you can check 4 times negative 1 is negative 4, and 4x minus 1x is 3x. If you were using a chart, like a little box, to do this with your coefficients, your box would look like this, with 1s in the first column and 4 and then negative 1 in the second. So x plus 4 times x minus 1. This bottom, or this denominator, is also a trinomial, and it can also be factored using the box method. If we were going to go about using the box method, we'd get the following box. It'd be a box with 2 and 1 in the first column, 5 and negative 1 in the second, because 2 times negative 1 is negative 2, 1 times 5 is 5. That would give us the factors 2x plus 5 and x minus 1. 2x plus 5 times x minus 1, and we could check 5x minus 2x is 3x, 5 times negative 1 is negative 5, 2x times x is 2x squared, and it factors nicely. Alright, so we've completed the factorization of each of the terms, of each of the polynomials. Alright, so we've completed the factorization of each of the polynomials. Now we need to cancel any common factor from numerator and denominator. So let's see. This x can't be canceled with anything in the bottom, but the 2x plus 5, notice that factor appears here in the numerator and here in the denominator, so that can be canceled. X plus 4 can likewise be canceled from a numerator and denominator. And x minus 1 can cancel from numerator and denominator, leaving us with 1s in every position. When we multiply straight across, what's that give us? That gives us that x times 1 times 1 times 1 times 1 is x. And x minus 4 times 1 times 1 times 1 is just x minus 4. We can't go any farther because x and x minus 4 are different factors. They're not the same. We can't cancel anything. So that's our final answer. Finally, example 1D. Multiply or divide is indicated. Write the result in lowest terms. 4 over 2c plus 2d divided by 6 over d squared minus c squared. Again, this is a division problem, and to divide two rational expressions, we want to invert the second and multiply. So that means we have 4 over 2c plus 2d times d squared minus c squared all over 6. Now, to multiply this out, the first thing we'd want to do is factor all of the polynomials so that we can cancel things that are like. So 4 is 2 times 2. 2c plus 2d, well, we can take out the common factor of 2. That leaves us with c plus d. D squared minus c squared, that's a difference of squares. D minus c times d plus c. And 6, that's equivalent to 3 times 2. So we factored all of our numerators and denominators. Now we cancel any like factors from numerator and denominator. Notice c plus d divides into both numerator and denominator. C plus d is equivalent to d plus c. That's because of the commutative rule. We can also cancel a factor of 2 here and cancel a factor of 2 here. Nothing else will cancel, so we multiply straight across. 1 times 1 times d minus c times 1 simply gives us d minus c. 1 times 1 times 1 times 3, don't forget the 3, gives us 3. So that tells us our final answer is simply d minus c all over 3.